Hello, testing. Let's see if we are on. I think we are. G'day, Het. Hope you're doing well. Just trying to get everything set up. We're ready to go. Chat. We have one viewer. Hello, whoever you are. Let's get started. Let's kick off straight away, actually. Just gotta open a few more things. All right. Let's do our first model, and we've got a few good ones to do from recent tournament, but let me just introduce what we're doing today for anyone watching the replay of the video. So welcome to Fully Defined. My name's Chris. I'm a certified expert, and today we are looking at practice models from TOBY'S website, and we're looking at the harder ones. So Tier 4, Tier 5, there's one Tier 6 model I haven't done, and we'll also look at some of the models from the recent last weekend's tournament, the finals, and maybe one or two guests joining us a bit later. Gummy, welcome. Thanks for stopping by. Hope you get plenty out of this one. And Monty, hello, welcome. So yeah, if you guys have any requests during the stream, just chuck them in the chat. Of course, you can go to the website if you're premium users, look through the premium models, pick any of those out that you would want me to have a go at. I do have a setup here that I have pre-selected to have a look at, a couple of Tier 5s and Tier 4s, and the Tier 6. We'll just mix them up a little bit. But yeah, we've got a pretty good hour and a half, 2 hours tonight of going through some SolidWorks. So for those that haven't jumped on before, we're looking at speed modeling, so it's efficiency of tool use, of sketches, but we still need to be accurate. So they are some different, let's say, workflows than what you might do in a normal day-to-day project, but these workflows do help you become more efficient when you do get into that workflow state in your job or school projects or whatever it might be. And that's where I think there's a lot of benefit to learning from speed modeling and seeing how other people do things. So yeah, let's get right in. We'll start with this Tier 4 model. Now, the way that I normally run these, or have done in the past, is we'll open up the model and have a look at the model, and I'll talk through my approach as we're going. Sometimes we might spend a bit of time planning out before we get into it. Other times we'll just go straight in and go for a speed model attempt. So yeah, we'll just play it by ear. And if there's any tools along the way that you guys see that you want me to have a crack at, just mention it. FP Kev, hello, thanks for stopping by. And Akira Mike, hello to you too. Alright, let's go with this tier 4 model. So I'm trying to do a bunch of different models as well. So tier 4, 5 and 6, but also I want to do some machine parts, do some 3D prints, do some multi-body, do some sheet metal, so that there's a bit of variety in there for anyone practicing or following along on the replays. Got any questions along the way, feel free to let me know as well. Now, the full screen, and the first one here, now one thing I haven't set up yet, which I'll just do now, is tweak this screen so that we can see everything at the same time. Give me a second to do that. I like to have it so you can see the models and the working out while I'm working through everything too. I'll just bring a few things up. Projects. Alright, so I normally have my properties bar up on the side so I can see my mass properties. And then we also have our templates here, 2 Tall Toby templates, which is pretty important when you're speed modeling. So let's jump into this first one, and I'm just going to open it up and just get right into it. So 3, 2, I might have to muck around a little bit on the screen to start, but that's all right. So I want to go open a new window here and get the larger screen open. Okay, millimeters and aluminium. Now this is a symmetry design with a pattern. There's a few ways we could do it. I would start with the central area, which we could do with a revolve. So I'm going to draw what we can see on the section. So the section view, we come out to the side, up, and we go straight up to the top. We come down, and then there's a couple of steps. So 1, 2, and then back to the start. I'm going to draw a construction line up the middle, and then I'm going to add my dimensions. And my very first dimension is actually going to set the scale of my sketch. So if you didn't know that, when I type in that number, it rescales all the sketch to match that first dimension that goes in, and it's a very good time saver. Here I'm going 35 divided by 2 for the angle, and I'm going to use the center line to put my diameters in. 70, 95. Okay, and now I can put on some other dimensions. So I'm going to go from the top, because those dimensions are exactly what we can see there. So we've got 70, we've got 120, and then we need our outside dimension. We can see it's 125 here. Now, let me fix that, a bit of a typo. And then the angle, or to the edge, we can see is 105. So now we've got a fully defined sketch. I'm going to revolve that. Alright, so that's the main central area, and then we've got the pattern sections. Now for the pattern sections, there's a few ways of doing it. I'm going to use the top. I'm going to actually sketch from this face here, and we can use the slot tool, come straight down and do that, and I'm going to convert this edge. I'm just going to delete that dimension and change this one. So I'm just looking for the dimension. It is 38 times 2. And then how far that comes out. I'm just looking for the outer dimension. I believe the center point of the circle is it, which is 225. So I can go 225 divided by 2. And that's the location. And then I can also do, you could do this with a hole wizard, but I'm going to just do it here, put that 20mm hole in, and I'm going to extrude, select this contour, put my thickness in. Thickness is 25, and it is offset 80 millimeters from this face. Alright, so we're going 80 then up. I can merge that. I'm going to do the next hole on top, which is 33, and that goes down 11 millimeters. And then we've got to do our rib. So we go on the right plane. With the rib, you just have to draw the line like this. It doesn't need to actually connect to both faces. You just need to get the angle correct, which is 30, as we can see here, and to the edge, it is 90 millimeters. And then when I go to the rib tool, I'll put my dimension in as 14. It actually fills in that whole gap. And so now I can select those 3 features and do a circular pattern around here. Change the instances to 3, and that should be the completed model. Answer 4285. There we go. Hello Dennis. Thanks for stopping by, mate. That was pretty good. 4 minutes 12, no issues, very clean model. Pretty efficient too. I don't think we could really do that much quicker. Yeah, what did you guys think? Thanks, Kev. Appreciate that. If we have a look at our speed, in the top 100 we rank number 5 at 4 minutes, just behind Dom, 30 seconds. Average solve time 11 minutes, first time 4 minutes, so pretty happy with that. Matab's done a tutorial on this one, nice one Matab. That is a pretty good start. Let's save that one away and move on to the next one. Color. Now I always like to add a color to my parts. And get my screenshots done early that I chuck in the thumbnail later. So this was the hub. Kev, okay. All cheated with the box section bench. Is that that model would be online, right? So if we go to TOBY'S website there, and we go to practice models, I'm going to assume you mean this one here. 2 minutes 32, the quickest one from Costco. How did everyone cheat? I haven't seen the stream yet. I just caught up on the World Champs stream yesterday. I will have to catch up on this one. Second practice model off the site, yeah. This one, RIGO Bench. First 42. Mess it makes, 21 seconds. But the speed runs, Costco the only one with a recorded version. Well done, Costco, in on shape. Let's give it a go. It's a tier 4, so we will get into it. RIGO bench, is it going to be wood? Let's reveal and open it up nice and large. Okay, Multi-body, graded one long piece, added all the lengths together rather than building a multi. Yeah, right, I get you. Well, to do it in 21 seconds, it's not so much building the proper model, but in that timer board there, that's one where you can just, if you know the answer, you can just input it. So people can just put a number in. If they know the answer, they can get 10 or 20 seconds. It doesn't really matter. Weldments, yeah, weldments would be great. I have the weldments certification, but I have not used weldments probably since I did that certification 10 years ago. That's just the work that I do is injection molding and machining, so never weldments. So it's good to see that. But I'll go through and show how we would do this in a reasonable way, not using weldments. Let's use multi-bodies. So it is plain carbon steel, inches, and we can see that there's a number of patterns. The profiles are all the same. The hint, use layouts, patterns, mirrors, frames, and or weldments. Yep. Alright, so I'm just wondering how we'd start this one. Whether you start from the top or you start from the legs. Because there's so much symmetry in this, that does speed a lot of things up. I'm going to start with the legs, and I'm going to do this in kind of maybe a quarter or a half. And if all the profiles are the same, why don't I actually show you guys a tutorial using blocks. Alright, so here's the example. We're going to draw the profile. It's 3 by 3, and we'll put the radius in 0.5. And then we'll offset for the thickness, which is 0.25 to the inside. So it's a fully defined sketch. And we're going to use the block tool, which is here, make block. Now I've used that by right click, tabs, toolbars and blocks. So blocks are essentially groups of sketches in SolidWorks, like you would group something in Illustrator or AutoCAD, etc. Now when I select it all and press block and save, it's going to include all these entities. Now although it doesn't say it, it also includes the dimensions that you have. Now once I press OK on the block, you can no longer see the dimensions. But the block is now a group of sketches that I can move around, and I can change the scale of the block. I can also change the angle. Alright, but where it's really useful is that I can make copies of it, so I can use that over and over. And I can still define to it, so I can grab that center point and drop it on the origin, and that's going to be basically fully defined. You can see it down here, fully defined. Hello Artse, hello Matab. Welcome. Congratulations Artse on your win. Matab, bad luck mate. You had a very good crack against Ricardo. It was really close. Yeah, very, very tight. So, good job. Keep practicing. I'm sure you'll get to that final four or later next time round. We're taking this one slow. I'm giving a tutorial here on blocks. So now, alright, I digress. So with the block here, I'm just going to save that sketch. And now I can copy paste that block. So I just go Control C, and I can go on my top sketch again. And I'm actually going to drop a block over here. And I can hide the first one. And if I want to dimension it, I can then just use the dimension tool, and 43 by 2, I can find the location that it needs to be. So I can fully define that. So it's going to be 7. Alright? And then you can use a block like you would anything else. So I can extrude this one up 9. And that one is then done. Now if I want to, I can use my planes, mirror. So I've got right plane and I would love to use the front plane as a secondary plane. Doesn't want to let me do it. Hold on, let me start that again. I'm going to go right plane mirror, secondary plane front, body here. Okay, uncheck merge. There are my legs. And then we can see on the next level there are another couple of parts that are joining it. Now what we can do, I have that block on my clipboard. I can start another sketch here on this face, and I can control V, and it's going to bring that block in, and I can just drop that block there. That's going to fully define it, okay, even though I can still rotate it. If I grab that and unchecked lock angle, then it wouldn't be fully defined. Alright, because then I could go like this and it's underdefined. If I grab the block, put that angle back to 0, press lock, it's once again fully defined. And then I can extrude it, and in this case I can go up to surface, uncheck merge, and leave it like that. So I can go mirror that body, that one's done. And then if we want to do the same in the middle, so I could go on the right plane for instance, and go here, put another block in, again move that block to that position, and you can actually, with blocks, you can also mirror them. Okay, so I can mirror that block to the other side, so I can do both of these at the same time. I'm then going to extrude up to this surface and up to this surface. Here, uncheck merge result. Alright, there's my frame using blocks. And then the very last one, let me go on the right plane. I'm going to put another block in, so another control V. I'm going to grab the center point and line that one up. Now, just got to move that. I'm going to extrude this one. This one's going to be mid-plane, 50, uncheck merge, and this time I'm going to pattern it. So I'm going to use front plane linear pattern. I'm going to use the body. I'm going to pattern it by 3, and I want 3 of these. And I want to go the other direction. Once again, I'm going to pick the front, or I could pick an edge. Also going to go 3. Pattern the seat only. Pardon me. Alright, there is our model. And our weight to 83. Let's see if that is correct. There we go. All done. Maybe not real view graphics for that one, but that is a completely different method to, I'm assuming, what most people would have done in that Model Monday Live. It is not the quickest, but it is quite a viable way of modeling for something like this. RIGO bench. Let me catch up on you guys here. I'd say no. I'd say you were great, mate. Very good. Was I awake at midnight? Matab, I was on a holiday and I was in a slightly different time zone. And when I was awake at about 7 in the morning, that was early enough to catch it. So yeah, that was good. Yep, the wheel's coming up. We'll do that one next. I'd say that's correct. Yeah, they don't have constraints, but sometimes you don't need that many. Yes, definitely I have an exploit. I think Onshape is very fast. Just depends on the user. So just depends. You see Victor and others using Onshape, they can be very quick. Airwick, very quick. Thank you, Kev, Artse. Yeah. If I was doing this one speed, I would probably just do extrudes, patterns, mirrors. But weldments is definitely the quicker way of doing it. I just I don't use it enough. Alright, so all the main characters are here. I think it's time to get onto that wheel. So, this is Arte and I have been talking about this a little bit yesterday. So I'll bring it up. I'll bring up the sketch. So anyone that wants to can grab a screenshot. And then I'll show you my process for doing this. What's it called? I'll find the name of the wheel from the weekend's matches. So here it is. This is the wheel and tire. Yeah. Alright, so this model, when you first look at this model, Arte, I'm sure you could probably talk us through it in the chat, but I'm sure you're like, what the hell? Where to focus your attention? There's so many, there's quite a few pink notes, you've got the sections, you've got lots of dimensions, you've got the patterns, you've got the detail view up the top. So I can absolutely understand where all your attention is split when you look at something like this for the first time. Such a challenge. No width dimension for the rim. There kind of is, but that's one of the things from a tab. It's like hard to see, hard to work out. The width dimension for the rim, like you've got this 20mm dimension up top. All right. The hint here is telling you actually how to sketch this. You've also got the 220, which is that section, and then you've got the 250 for the outer bit plus the arc. You're assuming that the arc is, the two outer points of the arc are both horizontal. Okay, it's not one higher than the other as well. So once you put the radius dimension in and you've got that outer points, that can work quite smoothly. So yeah, it was lots of fun watching the replay of this one. Arte and Sebastian both neck and neck. I must say I didn't really see where Sebastian went wrong. Wasn't looking that closely, like the dimensions he input or detail. Also, I don't really understand CATIA as much. But yeah, Arte got there through some very tricky backwards modelling. Just hacking your way through, which is what you got to do when you're getting into these harder models in the competition. And good news for Arte, he's going to get more chances to do tier 5 in the semi-finals coming up. Alright, so I'll take you through my process. Now I did do this, I did have a speed model attempt at this yesterday, and it was about 5 or 6 minutes from looking at it for a good 10 seconds and then starting. So I will use that same process here, and then we can talk about different ways of doing it. So the way I tackled this was immediately looking at the section view, because you're trying to set up the elements which aren't a pattern first. That was my approach. So I knew that the star, okay, the 5 elements that are patterned around, plus the holes and those chamfers on each of those spokes, the 5 of those, I could do one of those later and then pattern it. So that was really going to be the end point of my feature tree. So if you take that element out of it, then you're really starting with that the central area and the outside area. So you're starting with the tire, the round rim, and the central area which has the hole going through and the 45-degree chamfer on this edge. So that's the approach we'll take. And let me get into it now. I won't have the timer up because this isn't an official Toby on the website. It will be soon, and when it is, then I'll put a speed model attempt in. Alright, so multi-body, it doesn't actually matter which material you start with so long as you are in the right units, which is millimeters. I'm going to start with the aluminium alloy. So My approach was to go to the right plane and then basically try and copy all of the dimensions that we can see on this section view sketch. Now, very first up, I'm drawing out a line in the middle, which is going to be my center line, and I'm going to use that. It's good to get that center line in because we want to use some of these double dimensions that we can do the full diameter up and down. And then, funnily enough, my first sketch was this, to get that little section in the middle where the hole is. I don't want to do that in a hole wizard later. And I saw Art say in your attempt, you've done a couple of cuts to get the angles and everything there. You just put it in the revolve straight away. I'm not going to dimension it yet, because if I dimension it now, it's going to scale everything. What I want to do is actually draw more of this and then come back to it. So I'm going to draw up, across, and then we can see it's just got the angle all the way like that. Okay, and then we've got their main section. I'm not going to put this other hole in there. I'm going to leave that. I am though going to have to focus on how to do this section down the bottom where the chamfer is. But what I have to do is I have to flip it and put it up on the top side. And that is a little bit of a tricky element. All right, so I'm going to just draw this line in here and this edge down. And then I'm also going to draw in another line here to split or to create this gap. Okay, and so now we can add some dimensions. So overall, the whole thing is 220. So if I put that one in, that's going to scale everything in proportion. All right, and now when I add other dimensions, if I've kind of scaled it, if I've kind of sketched it reasonably accurately at this point, it's going to what's it going to do? It's going to keep all my dimensions, all my sketches pretty close. You know, so this one here, for instance, which is 15, when I put that in, it moves some things away, but generally, like, that's not too bad. That's still reasonably close to where it should be. So let's add some others in. So we get 18 across the middle. Now, trick, once you use one center line for your dimensions, you see that D and the construction line on my cursor. That means I can do others in a similar fashion, which makes sense to do something like this one, 40. Okay, this edge here. Now I have to try and find that dimension. For this dimension, I have to look at the side view or the front view, which is the 180, like that. I'm also going to look at the width here, which is 20. Now that's moved some things around. I'm just going to move that back out, put my angle in, 10. The center section, we can see we've got that 100 dimension. So that's where I'm going to this point. That's going to be 100. And then my section here, the counterbore with a sort of chamfer on it, that's 110 divided by 2. And then the depth of that is 5. All right, and then look at that. We've got a fully defined sketch for that first revolve. Now the other thing that we can do in this, which I did do, is put in the next section. All right, so I actually drew another line up here, put in my arc, put in the dimensions for these, looking at stuff like the little 10 mil distance here, getting these 2 points horizontal, putting the 250 dimension in, and this element, the tire, has a width of 25 as well. So putting that in. Okay, so now we've got most of the elements for that first section already sort of in place. Now I'm going to do a revolve, but we're going to select the contours for what we're going to actually include. Now first I'm going to do the aluminium sections. So I'm selecting those two contours and I'm just pressing OK. And then the next one, I'm selecting that sketch again, hitting revolve, select this contour, uncheck merge, Press OK, and there's my tyre. Alright, very, very neat and quick. I can come in here and just apply the material to this one. That's ABS. Let's just change it to that white colour. I'll just change it to black so that we can see that a bit easier. Alright. And we've got that conical section, and we're going to use that to extrude up to in the next step. Alright, so let's keep going now. So the next step is we want to do the first of those spokes. Now because we've got a flat face here, we can use that as a sketch, and all we really need to do is add in from this edge to here, and then we can mirror to the other side, and we're going to add some, I'm going to convert some edges, trim them off, and then this was a tricky one, finding this, how to fully define this blue line here, because we get the angle 15, you don't actually get another dimension. You have to see the pink note which says tangent, okay, which shows that the outer line is tangent with this circle, and that's why having that circle already done before you do this this element is really important, because that fully defines that spoke. Now when I did this myself the other night, I did it as a multi-body part and then patterned it, but you could do it as a merging feature, which we'll do on this one. It just means you have to merge these two bodies. That might cause some issues depending on how you do other things. We'll try it out and see how that goes. Alright, so we can now do our hole wizard. So I'm going to select that face, do a hole. I've got the same size there, so it's 6, 12 and 5. All I need to do is find the right position, and the position is 125 divided by 2 from the middle and in line with the origin. Okay, so we've got the hole wizard done. We've got some chamfers which are 4 by 45 millimeters, sorry, 4 millimeters by 45 degrees on these two edges. And then if we select those three elements and we do a circular pattern, change that to 5, press OK. That is complete, and there you go, we are done. The answer 2005, and that answer is there without me applying other materials, because the default material for this model is, I'm pretty sure it was aluminium, alloy, sorry, yeah, alloy. So I applied a material to the tyre, but I didn't have to apply material to this body. And that's it. Clean, yes. Thank you guys, thank you I'd say. It was a great example, and quite a sort of fun model to have a go at. I agree it would be very challenging on the live, in the live stream, especially head to head. This is much easier, calm, being able to see it, take your time and work through it. Thanks, Matab. It was, look, it's very, this, you kind of have to filter out all the stuff that's not important. So, like, you could see on this profile here, I could see, okay, the 10 degree, I see the 20 mil, I see the big diameters overall. The tricky part was finding this, like this edge here, and for that I just had to look across to this view where you've got the 100 millimeter and the 180 millimeter and put them across into the section view. And once I did that, it made things a lot smoother. Yeah, that can happen. He gave, I think I've seen that of Sebastian in the previous tournament, where he's much quicker, than most people. He's obviously very, very quick in the qualifying. In the live battles, he's still very quick, but he doesn't have the same level of accuracy and detail that other people might have, like Ricardo. He's very accurate with his dimensioning. I think he's probably going to go a long way in this comp. You might see him in the final, I'd say, actually. Yeah, that's all right, I'd say. That's all right, Matab. Okay, so let's have a go at our next model. Now, good to have a bunch of people on, 13 people here. Thank you very much for jumping in, guys. If you had any requests for tier 4, 5 or 6 models to go today, please let me know. I do have some up already, which I'm working my way through. I've done 2 tier 4s to start, so I think we're due to do a tier 5 part. And we're going to do this soap dish base. Yeah, I'd say very lucky. Very lucky indeed. All right. Ooh. That is interesting. Error. Let's see if we get that again. No, that's better. All right. Let's jump into the next one. This is going to be a ABS part, is my bet. We'll have a go at doing this as speed attempt. So I'll get it up on screen. Anyone else can take a screenshot. I'll give you 10 seconds to catch up, and then we will jump into it. All right. So get on. View. And here we go. Open a new window. Grab your, let me resize, move my head. Grab your screenshot, give you 10 seconds. This is a aluminium alloy part. Symmetrical, patterned. Nice challenge. Good tier 5, something that I'd say might definitely see in his final. Alright, so let's jump in. Now, so we can see down here, the bottom section, that there's some element that is not symmetrical, so you've got to keep that in mind. Okay, so we don't want to get it confused with the soap dish shelf, so we can skip that green element that's in there. We're doing all the blue part. I believe that cut in the end, we could do that very last, so you can kind of ignore it, do half the section and come back to it. I'm going to jump on the top plane, and I am going to try and do a quarter, because I know from Arte's reminders that it is always much quicker to do if you kind of know what you're doing. So I'm going to do this quarter. I'm going to do my outside radius. I'm going to extrude this up full height, 25. Alright, Matab, thank you very much for jumping on. Bad luck in the tournament. Good luck to Arte, yeah, definitely. Thank you, Matab. I'll see you later, mate. Have a good one. Alright, so we've got the extrude up. We're also going to do the outer fillet, which we can see is 12. Now this has like a 2-stepped cut that goes around. What I'm actually going to do is go the wall thickness, which is the 4. So shell at that thickness, and then on the top edge I'm going to select this edge, offset, and offsetting it 2. Yep. And then I'm going to actually convert the whole thing and then cut down by selecting this contour and selecting the distance to 10. Alright, so there's my little ledge. Now it says there's a full round fillet on the top. Alright, which is a bit hard to see, but we'll put that in, which just means a 1mm fillet on both edges. So we can do that one. Then I think we've done enough to mirror. I think we could do that rib at the end. Oh, it does have fillets one side. Actually, let's try and put it in because we're right here. So I'm going to draw this shape here. I want to make sure I get that fully defined on that edge. We're going to put then in a hole. Just looking for the hole detail. So it's a semicircle that has a radius of 5, so it's 10 like this. Can just trim that. I need to put the next one in as well. Another one. And the distance apart is 14. Okay, so then I can extrude that. Now the total thickness of that section is 2, so if I go 1 millimeter in this direction and select that contour, that's going to be enough. I can put the fillets in here. That's going to save me some time, so it's got an R2 fillet. 2, 2. Alright, now we should be ready to do a double mirror. So I'm going to select these two planes, select this body, merge it. Okay, so the full body's done. Now we just need to do that cut. Now how is the cut done? It's a slot that's going through two ways. I'm going to do it on the front plane. I'm going to use the slot tool and put in the measurements that we need. So it's 22 to the outside edge, and the height of the slot is 6 millimeters from the bottom. Alright, so that's fine, it can be underdefined. How deep does it cut? It cuts 22. So what I'm actually going to do is just change the sketch plane, put it on this edge. Then I'm going to cut it 22 millimeters that way. And then all I need to do here is a full round fillet or a 2.5 millimeter fillet on these edges, and this should be it. So 101.4 should be the answer. There we go. 5 minutes 30, tier 5 model. I think that's decent. I think that is pretty good. How did you guys go? Let me save it. I'd say you got 102, you would be wrong. Sorry mate, you're out of tolerance. Where could you be wrong? Good question. Thank you, Gummy. I was happy with that. I used Artse's own moves against him for the double model, the double mirror. It's really good. I really like it. I'd say, have you worked it out? FPP Kev, you'll have to back up in the stream and see how it was done. 5 minutes. Yeah, definitely neat. You forgot the R1 on the top. Yep, this one. Good tutorial here. Couple of tutorials. Rich Pen getting in there. Tandaflan. Couple of guys getting around the tutorials. Awesome. The maths is 101.4. 101.4 with a tolerance tolerance of 0.2. So you'd need to be 101.6, 101.2 to be within tolerance. Yep, I think you're still wrong. So there might be something else. And if you've done everything else correctly, I'd say it's most likely that it's somewhere around the cutout that you've done, that you've gone wrong. Because this is the only area that's not symmetrical with everything else. So that's probably the place to start. Are your dimensions okay for all of that? 101.95, I'll try. Incorrect. Nice try. But yeah, I think you need to be between 101.2 and 101.6. Alright, great challenge. Let's do let's step it up. This is the last tier 6 model that I have not done yet on the website. So, should be a good challenge. It is a multi-material with sweeps and symmetries and thin walls. And it looks like a piece of furniture. I'd say, alright, let's have a look at Artse's file first and try and help him solve this challenge. Alright, where's Artse gone wrong? 101.95. And if we look at my file, so I'll show you guys a tool which you may not have seen before in use. It is the compare tool. So you go to tools, compare, you can go to geometry. The reference document, you just pick one, and then the modified document, and run comparison, and it's going to compare those two. Alright. And then if we look at either material to remove or material to add, let's see if we can work out what's missing. So if we look, it's not always the easiest. Can't see anything really obvious on this one. I'm going to try another method. I don't always like using compare. So this is my version. I'm just going to change the body appearance to green, and I'm going to insert part. I'm going to insert Artse's version. And I'm going to assume that he's done the right overall dimensions so that these faces can match. And then we can just see it in the same file. You can do the same thing in an assembly. Alright, but here, look, this, we can see pretty quickly now where his issue is. Here. So, I'd say your holes are too small, and that's why you got extra material. That's too big. So those holes should have been 10mm in diameter, and yours are 5mm. There you go. Easy miss. I hope that helped. Alright, let's jump into the next model. Pleasure, mate. Alright, here we go. Aaron C model. Very good. Tier 6. We're going to have a go at doing this as fast as we can off the bat. Alright, so we'll just go straight in. I will give you guys 10 seconds. Take a screenshot. Follow along. After that, I might reset the timer and then go. Alright? So, reveal. Open. Grab your screenshots. It is multi-body, multi-material. I've done this model before, but maybe never on the, obviously not on the actual practice models. I'm going to restart the timer so I can have a realistic time, and now let's do it. So I'm going to grab the most common material, which is ABS, and it's inches. Ugh. All right. Now it has a continuous sweep that goes all the way around, and a section where it kind of gets thinner, which makes it difficult. The easy parts are the seats. The seats have some indented geometry, so we want to remove that. Let's start with the seats because they're the easiest parts, and maybe that geometry can help. Or maybe we should do as much geometry as we can of the whole thing. I think we actually do that. We're going to do it like this. We're going to do the straight sections. I want to get the center line of that tube, and put as much in as I can. I think this is how I did it last time. I think I put a point here. I can remember putting a point there, and I think that's going to come in handy. Oh, not like that though. Oh boy. It's because we put that 10mm dimension in. The angle 10. I think that's ruined our scaling. That's better. Alright, now put the 10. Alright, what else do we need? Going from center to top 80. Going from here to here 50. Straight section 8, we'll come back to that. Angle of this one 30. Don't want that dimension. This is a very difficult model. I want to get those seat elements in. The tube, let's just look at the tube and get a bit more tube done. I want to offset geometry, but I do want to get the radiuses in. Are the radiuses the center of the tube? It looks like it. Which means we can put in the R6 here and the R3 at the bottom. What's that bottom one? That radius there. Doesn't quite say. We do get a dimension here, 10. We get the straight section here of 8. All dimensions are to the tube and bar center lines. That's useful. I want to put in everything in this sketch. So we're going to put those benches in. Now are they coincident with the edge? It says 1.5 mil off to the side. This is where it's a bit hard to see. No, see, it's offset here. So it's offset towards the front. But that's from the thickness of the tube. The total tube is, it's 2 mil solid bar, 3 mil tube, 3 mil tube. Okay. Oh, I still don't have those radiuses. 50 mil to the start of the bend. So I'm just going to put a temporary one in here and here, so that I can put this dimension in and try and find those other dimensions. I'm trying to find this arc. Solid bar R12. 1, 2, 3, 4, 5, 6. Yep, these are 12. Okay, that works really well. Now we can do the offset, which is going to be 1.5, select chain, bidirectional. Offset geometry is going to be for construction. We don't need to cut the ends. Alright, so then we get our tubes. Now with our tube outline, we can do our bench seat, which is like this. The bench seat is 24 by 4. It is offset 1.5 from the back. Got to make sure I'm not going too far over the edge. 1.5 from the back means it's on the center line, which that would have made things a lot easier if I'd just done that to start. So the other one we can just put on that center line, and the dimension of that is 4 by 24. So that bench is 4 millimeters from that point of the tube. Okay. It also has a 2 millimeter radius on the top, which, let's put it in. So there, and there. Okay, that one's fully defined. This one over here is then a gap 18 mil bench to bench. Alright, is there anything else we need in this sketch? I don't think so. Alright, so there's a lot in that sketch. It's probably not easy to just use that sketch. We might just do a right plane. I'm going to convert everything. I'm going to select this chain and delete it, and then I've just got the bench seats, and both bench seats are the same width, which is 72. Just going to do those mid-plane. The bench seats are already ABS, so they're fine. I don't need to do anything else to those. Now I need to convert the entire tube, but what I want to do is half of the tube. I want to get an edge for the tube. I could do a 3D sketch, which would work, which means I can do right plane. I'm going to offset this 72 divided by 2 here, and on this plane I'm going to convert that sketch. Just get rid of this and this. Alright, I could have just put it, I actually don't need a plane. I could totally skip the plane and just put it on that face. Right. And then I'm going to do if I convert this to a 3D sketch, so I do 3D sketch, convert that edge, I'm going to do a line from here to here, and I'm going to put a 12mm radius on that point. Alright, so that one's done. Now with this, I can do a sweep. Now the tube, it's solid. Not quite. Tube geometry. Okay, so it's a hollow tube on the outside, and then it's solid bar in the middle. I think the tube has a 1/2 mm thickness. Can't see that though, but I think it's to do with this sticking in section. So what I'm going to do is a sweep, circular profile, 3mm, thin feature, 0.5 to the inside, uncheck merge result. Alright, then how are we going to do the next part? Because what I need to do is trim back and actually extend this one. That's where that point comes into it. Actually think I'm going to change something. Is I'm going to put this point in. I'm going to put this point in here to split it. Will it let me split it? Yep. I want that to be in line with that one, so that is along X. Then I'm going to select the rest of this, make it for construction. Right, so then I get that tube. Now that one's done. I just need to mirror it and merge. That is the main bar. That is a plain carbon steel. Okay, and then we have the next section. So for this, I'm going to do another sketch. I'm going to show this one. I'm going to select these lines and convert. Just extend that edge, and it says it goes 8mm in, right? So I'm going to go to the side view, change that to 8mm, and when I do a sweep of this one, I'm going to make it solid, so no thin feature. Uncheck merge, change the material of this one to alloy, and mirror it. Will mirroring apply the material? Yes, it looks like it will. This could be the right answer, 854.7. No, okay. 845.5. I think you probably could be right, I'd say. 845.5. No, 845.5 is also wrong. So there is something we're missing. I'm just going to make sure I've added the materials to everything I need. 845.7 is wrong. Alright, good challenge here, tier 6. And we have something going on. Oh, we haven't removed the material. That's what we haven't done yet. So, we need to do the indent. No, I know what it is. I'd say we haven't done this tube geometry removed from the benches. Yep. So, in this instance, in the comp, I would have got a wrong answer. Then we have to work out how to fix it. The correct way to do this is use the indent tool. Indent. Our target body is this. So we're going to do it one at a time. Our tool body is this tube. We're going to cut, and I'm going to press OK. And it removes the material, but I've got these little bits left over which I want to hide. So I don't want them. And then I want to repeat the process for the bottom one. Now there is another way to do this, which is a swept cut, which you could also do, but we're just moving quickly here to fix it. So indent, indent, remove those ones. So when they're hidden, those bodies are hidden, they're no longer counted. I can see the answer now, 847.4. 847.4. Still wrong. Alright. More work to do. What is this material? ABS. This material, ABS. Alloy, alloy, alloy. Let's delete these bodies. 847.4. We are still wrong. Pounds, not grams. Yeah, I'm in inches. I'm in pounds. 847.4 is not within tolerance, is not the correct answer. And we've probably lost our shot in the tournament now. Aaron C. Practice models. Alright. What else can we look at? Yeah, red marker is what we do on this next one. So we can try that. Before we do that, just want to have a look at both of these just to make sure I've got everything right. Have I got the materials wrong? Main bar. Item number 3. Plain carbon steel. That's right. And then the smaller ones are both alloy. There's 2 of those. And then the seat's ABS. Materials are correct. There's no problem there. Let's just show the hollow tube. Hide our sketches. Hollow tube looks okay. Just trying to inspect the model, see where we've gone wrong. I think we'll go to a marker. So I'll show you how we do that. Grab the model. I'm going to bring this over here. And now we're going to go through and work out where we've gone wrong. So, right plane. Our first sketch. There's a lot of places we could go wrong here. So we've got 50, 10 to the center of 2mm solid bar, 50 center to the start of the bend. Yeah. 18 from bench to bench. 80 for the full height. From the origin to the top. Yep. 30 degrees. We've got the 42 8mm. The distance the 2mm bar sticks into the 3mm tube. That's right. Am I sure that radiuses are center radiuses? I think so. Because when we look at this, like you can see in the sketch here, like the arrow, it's pointing to the center. Plus, in the note here, all dimensions are to the tube and bar center lines. That's what tells us that that is correct. So these ones here are 3, R6, straight section, 10 degrees, 2mm bar. What else? We have the 4mm, we have the 24mm bench. The 1.5 is the thickness of the bar, and that one, we have 4mm bench. We have the radiuses, 2, and 24 is correct, 4. I think I might be correct everywhere too. Then we have 72, center to center and bench to bench. 3mm tube, 2mm ID, 2-inch ID, and 12 for the radiuses, which we did in this 3D sketch here. It's all the dimensions. Yep. Something is going a bit wrong. I have a feeling I've done this model before. So I'm just going to see if we can find it. I hate to leave a model unfinished like this. And I know it's not the most exciting, but it's pretty important that we work out what we're doing wrong. So let's have a look at some of my models. This is a bench seat. Now I don't think we've done it in practice before. So I'm not expecting to see it in this folder. Notch out for the tube, need tightening up at the back. I think you're probably talking about that part there maybe. I don't think it does. I think those are in the drawings as well. Even this is a bit weird though, this one. I reckon that's where it could be, like in this area. Let me just have a look at these models. I think we might find it. I've done it before. Here it is, Aaron C. Bench, if that loads. Yep. I might crash SolidWorks right now. Come on. Alright. Now in this version we did it a lot differently. We did a surface extrude. This is actually nice and clean. Surface trim, compound curve sweep. But look, the body, the cut's a lot different in this one. The answer's a lot different too. It's different materials. Alloy plain carbon steel. Well, actually, maybe that's the correct answer. Maybe what's different in this one? No, it's different dimensions. But yeah, those look a lot different. Those cuts, particularly this cut down here. Maybe it's that dimension that is somehow wrong. I actually didn't dimension that one properly. So while that one is 12, why have I got a 5 here? I think that's the wrong one. The area where it says clean, what exactly does it mean? Can't really see on my phone. Hello Gray, good to know it's not just us. that area where it says clean, what exactly does that mean? Okay, where it says clean, it's a great question. So what Guy is asking about is this section. I can't zoom on this one. This section here. Well, I think it just means it's a clean cut. I can still see some geometry, like little edge detail there. So it's not that, but I actually think I've found the problem. I think it's this radius right here. This is supposed to be 12. That was a mistake. I think I put that temporary 5mm radius in there and forgot to take it out. So now that's going to put our answer to 845.5. I'm pretty sure this will be right. Yeah. Damn, 24 minutes. It's very slow. Probably not posting that one. Top time, Lodos, 2 minutes 30. Awesome. We're right down here. But we got it done. Thanks for sticking with me. Let's save this one and move on quickly to something a bit less crap. That was not a good one. All right. Yep, so easy. Can I send you this model? I cannot say, but it's SolidWorks 2023. I don't know if you can open it, but I can send it to you. You said 845.5 before, did you? You did. I thought I put it in. You were right. Well done. I'll check the stream. I thought I put that in and I thought it said wrong, but maybe I put a different number. Sorry about that, but well done. I'd say I had it the whole time. Yeah, I can see it. Let's see. We go up a bit there. It's right there. Yep. Well done, mate. That's why you're in the top 4 and I'm not. So good stuff. All right, what model should we do next then? We've got a tier 5 machine part, a tier 5 sheet metal, a tier 4 sheet metal, and a tier 4 swoopy lofty. What should we try? Let me try it. Oh, next. There we go. What are we doing next? Tier 4 or tier 5? 30 seconds. And we'll get into it. There's 10 people here, so whichever one can get the most votes. Looks like it's tier 5. I see 1 vote. Four votes, tier 5. Alright. Tier 5 it is. People have spoken. We're going to do this one right here. Once my thing updates, tier 5 valve body. Let's jump in. bring it up so everyone can have a look. There we go. Another inches one, plain carbon steel. Grab your screenshots and we'll give it a go. Thanks to Toby for his models, practice models. Love your work, Toby. And I had asked Toby before if it was okay if I show these on live stream, these premium ones, and he said yes. So thank you, mate. People appreciate it. Alright, let's cancel, let's start again. And let's do this. Now there's symmetry in this, so we want to use that to our advantage. There's also that sphere shape. We could do probably a bit of a revolve with this one. I think. So I might just start on the front plane and look at section AA. Is it symmetrical? Maybe. So can we do this? We'll find out. So double symmetry. I'm gonna give it a go. Well, I probably don't want to do an arc like that. I want to do it more like this. And sketch the shape down. Across, what's the thickness? 0.625. No, reverse. Okay. Alright, let's get some dimensions going. Hole through the middle, 2.875. From the outside, 4.125. Yep. Doesn't like it. I have to come back to that one. Whoa. Here to here, 8.625. Great, look at this. Oof. How am I going to fix this? Like that. And like that. Yep, so we don't know that radius. 2.25. Thickness that 1. Outside to outside is 10. Here to here's 13. Does that look right? I don't think that looks right. There's something going on here. Doesn't look right at all. .125. Well, what's the thickness then? That's not right. There's something that I've done that's a bit funny, which doesn't want it to work. We can see that the radius outside is a question mark, which is fine, but the thickness looks like it should be the same. Okay. This dimension here, that's not good. That was the one, I think. Although that doesn't want to work either. I'm going to delete that. They should be though concentric. Thank you. That and that should be vertical. Coincident? Yep. I think I just need to do this. That's better. Alright, there we go. Now we can revolve that. And let's get our holes on the outside. 0.875. Yeah, we've gone very slow with this one. Unfortunately, it's just how it is. Do a circular pattern. There is 8 holes. 6 holes. Not going to fully define it. Just going to cut up to here. Let's mirror, merge, and then we want to do the front one, which we have the details we can do on the top plane. So I'm doing a construction line through the middle, and I'm going to sketch my shape very quickly. 8, 6.25, the thickness 0.75, distance to the origin 7.5. What's the hole through the middle? 3.5. 92.81 for Atse. Grey. You guys are pretty quick. You guys are very quick. I think your numbers look pretty good. We will find out. Just going to bring that to that edge, that way it's fully defined. Then I'm going to revolve this. I'm going to merge, and the way to get rid of this element in the middle and that element on the inside, it's not the nicest, but I wonder if we can just do a delete face to get it done. I've just hacked off that first one. Do I get rid of that one too and that one? Not that one? Not that one? Just need to have a look at this to see what shape I'm getting on the inside. I need to get rid of that face there. And I'm not sure if I can just do it here. No, it doesn't want to delete face. What I need to do is revolve cut. Separate delete faces. Yeah, delete faces you're a bit of a hack here just to try and get it done quickly, but it's actually slowing it down. I'm probably within tolerance. No, 92.6. No, not quite within tolerance. If I want to do it properly, I can use this and do a revolve cut. but I have to like tweak the sketch, which is annoying. Convert, mirror, bring it down to the middle, make that vertical, get that on the origin, then do a revolve cut that's around here. That gets rid of that section. Then it's 92.4. No. What did you guys have? 92.8. 92.8. Did I get rid of too much material? What's the correct answer? 92.8. Yeah, intersect is also a good one. Right, so I'm wrong. You guys are right. Oh, the fillet. Right. Didn't put that fillet in before I mirrored. That was where I went wrong here. So that has a... I'm looking for it. 0.5. There we go. 92.8. Well done. First one in there was grey, followed by I'd say. Good stuff, guys. I'll submit that. It's close enough. But not super fast, were we? We're quite down. 10 minutes. But we could do that one a lot quicker, I think, if we were doing it again. Yeah, thanks, I'd say. Got your files. Let me just save this one. We will move on. Oh, look at that. Alright, we'll have to do another tier 5 because we weren't very quick or clean on that at all. The inches kind of throws me, but that's not really a good excuse. Alright, so the next tier 5 was sheet metal. Alright. Not my best either. But average time is 16 minutes. Top time is 52 seconds. And then Sebastian, 2 minutes 52. Gummy, 4 minutes. If you're still here, Gummy, if that's you, very quick. We'll give it a go. Sheet metal, let's guess. Alloy. Straight into it. 3. I'll give you guys a chance to get the screenshot. Hold on. Alright. Take your picture. Plain carbon steel. 3mm thickness, 4mm bends. And alright, let me get that into the right position and then we'll restart. Cancel, reveal, let's go. Plain carbon steel. Symmetrical sheet metal too. Yeah, I'm not very good at sheet metal either. The corners on this one are tricky. But the main width being 80, I think that's where we start. So this kind of side profile. So I'm going to go like this, all the way up, and put these dimensions in. Alright, so the wall thickness is 3, outside to outside is 63, which means we want to make this 60. And then this is outside to outside 121. Do we want to take 3 off that? Maybe. And 27 for this, which might make it 24. We'll have to come back and double check some of these. I expect that one to be in line with that. So then we go sheet metal. Distance is 80. We go mid-plane. Or should we do half? We should probably do half. Blind. Thickness 3. Bend radius 4. I'm going outside. Alright, so we need to tweak this dimension, take off another 3, and this one 21, we want that to be 27, so we actually need to add on 6. 30. Okay, so we've got those done. Going to add a break corner here that's going to be 15. May as well get this hole in here as well. The hole is 9. It's 140 from the top. Sometimes just getting through like the simple features quick is good, you know. Don't need to overthink it. Just want to put some pressure on your opponent. Because here now we're going to do an edge flange. Okay, now that edge flange is coming right out to that end point, so I want to go up to vertex. There. And where the bend is happening, the bend's happening to the outside. And even like this, we can offset it. Now, I wonder if that might just be the perfect dimension like that. So we've got 80 for the edge, 40. Let's halve it all. Okay, so you've got 40, then you've got 47. So there should be a 7mm difference, which is your thickness plus the radius. So this should be the right answer, like this. And now the height of this side tab, you can see it's 7mm off the bottom, which we have correct as well. It's the radius plus the thickness. So this should be good. That should be super fast to do that one. Then we've got another edge flange, which is coming in the top here. But this one is going to be inside. But we actually want to get it right up on that edge. You can see it's coincident. This will actually give you an error in SolidWorks, I think. I want to offset it up. I also want to edit the profile, bring this edge in, because that is going to be 35. Okay. And how far does it go in? It goes in 30. So I'm going to go back, and I'm going to say, hold on guys, I want to be here. I want the length to be 30. Let's see if that works. And then the gap between them, I want it to be almost nothing, so I need to reduce that. So I'm going to offset it by 1. Alright, you see I get that error, but in this speed modeling I don't care about that error. And now I can just tweak this. What I need to do is just get the right size for this cutout, which is 4 and 10 from that edge. Okay, link to thickness. Alright, so that's done. The bend's looking alright. We have a break corner here, which could just be a fillet again, but we can put it in. It's 10. Artse's flown by on this one. Nice one, Artse. We've got some slots. The slots are R5, which is 10. Their width is 40. It is 8 to the slot, and there's 5 of those slots. So we're going to linear pattern them, and those slots are 15 apart. Didn't want to dimension it for me, thank you. And where is the first slot? 31 from the top, cut into thickness. Are we done? I think we might be done. Mirror, body, merge, 740.4. with a tolerance plus or minus 1 gram. I'd say you are wrong, mate. Sorry, buddy. A bit more practice for I'd say. 745, I'd say. So you've got something a bit off, mate. The answer is 740. Plus or minus 1 gram. I'm within tolerance. I'm glad I got that right, and that 6 minutes 54 for tier 5 sheet metal is reasonable. I think there's a few guys that could do quicker, but I'm pretty happy with that. Let's save it. Thank you, Kev. Appreciate it. So I'd say his answer 745.7. Incorrect, not within tolerance. Found your mistake. Nice one, mate. GG. Very good. Alright, guys. We've been going nearly for 2 hours. I reckon we'll do one more model. So I had some tier 4 ones up here. I think maybe we'll finish off these 2. And that'll do us. If these are quick, we'll get through both. So let's jump into this one. Machined part. Actually looks really simple. Tier 4. Aluminium alloy. A little bit of symmetry. And some parts that aren't symmetric, which are these draft angles. Let's give it a go. I'm going to restart. And aluminium alloy. And I'm going to start with the revolve on the right side. And it's got a hole that goes all the way through. Yes, it does. So we can use that. And that is 200. And then we're going up. The outside, the biggest one is 155. I'll come back to that. It's 35 across, down, through, up, across, down. The front one is 25. We said the hole in the middle was 45 through all. And the main section is 75. At the front we have 110, and at the rear 155. So we revolve that, and then we've got the section in the middle. Section in the middle we're going to sketch on the front plane. And how are we going to do this? It's got a vertical wall that comes up from here. Then it's got an arc. Then it's got another vertical wall. Then it's got an angled section. Then it comes back to the middle. Then we want to mirror that and convert that, sketch that, and then dimensions. So 175, 45, 60, 150 from the origin. The arc section, 70. What about that angle, 90? And the vertical wall bit, what's not fully defined here? Where it starts. Okay, it's going to be horizontal there. Okay, that's fully defined. Now we want to extrude it, and we've got the dimensions for the top, so that's okay. We're going to go mid-plane, so we're going to, sorry, distance 50, blind. Going to offset it 70 from here, and we can merge result, and then we're going to draft. So we're going to draft this one 10 degrees, parting lines here. SolidWorks is frozen. I think I have frozen my model. I was really flying too. 3 minutes in. I can tell I've frozen because it's unresponsive. I can't do anything with the software. I can Alt-Tab between things, but unfortunately, yeah, SolidWorks crash. I only had 2 steps left to go, which was going to be a draft on this edge down to this face, and then a second draft on this edge down the other way. One's 10, one's 5 degrees. Then I should have the answer. Away you go. It will not recover. It's very unfortunate. So frustrating. Alright, well, let's do our speed run. We've done the tutorial. Let's restart it. I'll just get through as quick as I can. See if I can beat that 3 minutes. 3, 2, 1, go. Alright, right plane. Construction line. And then new line. 200. Up, across, 35. $45 for that one, 110 for this one, 155 for this one, 75, 25. I think we can do it quicker. Because we're basically done after we do this sketch, right? So we're going up, angle out, up, up, across, mirror, convert, trim, make that horizontal, and then dimensions. So we've just got to race through these dimensions. 60, 45, 45, 150. What else? 175. Okay. Extrude was 50, offset 70. Just going to save it so I don't lose it. Draft, direction, edge, back, 10, same again, edge, 5, and answer 5824. There we go. Yeah, yeah, that DOM, I still remember that. That was so unlucky. Real, and he came back as well. He actually got pretty close. This is a pretty neat, easy sort of tier model, I think, tier 4. But anyone that isn't really comfortable with the draft tool, that would definitely be tricky for them. I'd say you got to clean up a bit, mate. Ready for next week. What did you get wrong? Where did you get stuck? You need more practice. Oh, 28 seconds. The quickest ones. Look at these. These people doing it in 1 minute. 44 seconds. But no speed runs. Do you know where you went wrong, I'd say? Let's just put it in. I'll show you. Your thickness here is wrong. Alright, I'd say. So everything's right, it's just that front dimension. That's it. Easy miss, but that's yeah, what you got. Bad luck. Alright, last model, guys. Last one for the night. Thank you to everyone that jumped on and had a chat. Great to have you. Let's get this last one. Swoopy lofty, it's got some sweep and some symmetry. These are an anchor plate. Let me bring it up. We can have a look together, and then I'll do the speed run. So grab your screenshot. It is carbon steel, millimeters. It's got symmetry we will have a go at for sure. Alright, let me restart. And let's go. Plain carbon steel. I think you just do, so simple, I think you just do the whole thing in one go. Maybe not. Make those equal, make this vertical, internal radius 25, external radius 8 for these. Yep. Total width 110. So we'll do a thin feature extrude on this one, or we could, it's probably thin feature. It's probably thin feature, 25. Okay, so extrude, thin feature, we put the thickness in, which is 4. Flip the direction, change the distance. The total distance is 150. And I'm going to then use, do some fillets. So the fillets are 9. I want to do it on all 4 of those edges. Like that. I've got a couple of holes to put in. The holes 84/16. So you could do a thing like this, 90 by 84. Make it all for construction. Get that in the right spot, then do your holes. The holes are 12. I'll just draw all my holes, make them all equal. Get this dimension right here, which is 16. Cut the holes. Okay, then we just need to do the loft at the end. You could either exploit this, we won't. What I'll do is put a plane here, offset that plane by 15 on that plane. Then I'm going to do a sketch, which is a slot. And the distance of that is radius of 40. What is the height? Total height is 60 from the origin. Grab that. If I just trim that, I'm going to lose the slot detail, but that's fine, because I just want to select that now and do a sweep and make a circular profile which has diameter of 20. And that should be the answer, 1416. Done. That was pretty neat, pretty quick. Yeah, you probably get a little bit quicker with, you know, maybe not mirror, maybe using some mirror, some symmetry, but I'm pretty happy with that. All right. Thank you, everyone. Anyone have any questions or feedback before I log off and go edit the video and put all the tutorials in? Was great to have 10 plus of you here jumping on tonight. My next series of projects, we're looking at doing the I'll be starting that build and learn series, that motorcycle, building those parts are on my go. So if you're not subscribed, please jump on. I'd say my pleasure. I think there's a break this weekend, right? So in 2 weeks, we'll see you in the finals. I'm at Tab. Welcome back. Just about to log off. But there's another bunch of models for you to follow up on. So, yep, have a look through the replay. Keep up the good work, mate, as well, with your own videos. It's good to see. FPV Kev, thank you. Gummy, thank you. Gray, Akira, Guy W. I think the main guys that were in the chat tonight. Het Patel, I'm not sure if you're still there, but thank you as well. So if you're curious what I do after the stream, I actually go through the YouTube video and I will identify the timestamps for each of the tutorials. I'll chapter the stream so it's broken up into sections, and then I'll link each of the chapters onto the Too Tall Toby website, and that's how I get my tutorials in there for a lot of the models that I've done, and also my speed runs. If I've done a speed run, I'll link that in too. I've seen some info from Hooby that's shown me that I have the highest number of tutorials, which I'm pretty happy with. There is a tutorials leaderboard, which I'm currently leading. 51 tutorials. Above Toby. That doesn't quite count, but yeah, getting in there, getting up there, which is good. SolidWorks, I am the #1 ranked SolidWorks World Champ until Atse or Ricardo gets to the final. Assuming they'll get to the final. I think they will. So anyone that's, I'll just share some other stuff while I'm seeing if there's any other questions from you guys. So I've got a couple of things that I'm working on. The Fully Defined website. There's work in progress. Kind of captures a bunch of my stuff. So intro video from the channel, you would have seen that. Shows the one and only course that I have recorded, but if anyone was curious, you could check that out. That's really for beginners, for fundamentals. Shows a bunch of my videos. Also gives you links to my Lego projects. A couple of links to me and some fact stuff. You can look into the Lego video library. This has all the videos from the Lego project. Same stuff that's on YouTube, but it's all in one place. I've got a few more to add in. And the other thing that I am building is a bit of a school community, but that's really got a lot of work to do before it's something I'll promote. Het's in there at the moment giving me some feedback. Well, he will at some point. But yeah, I'm just trying to put everything together in a few places, trying to consolidate so that when I do the streams, when I do the recordings, when I have files to share, people can check it out. The one thing I will actually show is this database that I'm working on, which you might find interesting. Got it. This is the Fully Defined CAD library. Where I am capturing all of the Lego parts that I'm creating where the videos are for those and their difficulty. So it's a bit of a different play on like the practice models library that TOBY'S done, but these are actually for parts that you can then put together into an assemblies to build your Lego components. And this one contains everything to build these assemblies. So you could actually go to this. You can download the SolidWorks files if you've got SolidWorks 2023 or newer, or there'll be linked to the step file folder where you can download step files. You can see how the parts are built. If you've got SolidWorks, if you've got steps, you can just recreate them. There are some videos to show that too. And then you can practice, do your own assembly practice. So this is something I'm building at. Yeah, when it's all ready, I'll put some stuff out. And I'm sure you guys will see the notifications if you're subscribed to the either email list or YouTube. So thank you again. All right, that'll do. Thanks very much, everyone. Have a great week, and I'll catch you in the next one. See ya.